Welcome to the deep dive. Today we're looking at something still incredibly relevant, COVID-19. Specifically, its origins and its lasting impact.
That's right. There's some new research that really shifts our perspective on how it might have started.
And also, some quite concerning findings about long COVID, plus an update on where things stand now.
Exactly. We've pulled together insights from a few key sources for this. There's a big paper in Cell just out this week, May 7th, 2025.
Okay.
Plus, research from the Journal of Nuclear Medicine on long COVID, the study in Nature Immunology, and the latest data from Australia. It's all curated via DTE.
Got it. So our goal here is really to break down what's new and what you need to know about COVID's origins and ongoing effects.
Precisely, to give you a clear, concise picture of the current landscape.
Okay, let's dive right in then. The origin story. It's been debated endlessly, hasn't it? But this Cell paper seems, well, pretty significant.
It really does. It makes it a very strong case that the virus probably didn't jump directly from bats to people as the main route.
Oh, interesting. So not the simple bat-to-human jump we first heard about.
It seems less likely is the primary pathway. The evidence is pointing more towards the wildlife trade, involving intermediate animal hosts, like a stepping stone.
Right. But we know bats carry these kinds of viruses, so what's the evidence for this extra step?
Well, there's several points. First, just look at the geography. The bats known to carry similar viruses are mainly found way over in western China or maybe northern Laos.
Okay.
But the first human outbreak was detected in Wuhan, central China. That's a distance of over 2,700 kilometers.
Wow. Okay, that's huge. That's not exactly next door.
Not at all. And the bats themselves, these horseshoe bats that carry sarbecoviruses, their natural range is tiny, maybe just 2 or 3 kilometers. They don't fly cross-country.
So they couldn't have naturally flown that far in the time frame we're talking about.
Highly unlikely. So the question becomes, how did the virus bridge that gap?
Yeah.
So the researchers look closely at the virus's genes, specifically parts of the RNA genome that don't change much during replication or jumps between species. They call them non-recombining regions.
Kind of like genetic fingerprints.
Sort of, yeah. Stable markers.
Mm-hmm.
And tracing these back, they found that the closest ancestors of both SARS-CoV-1, the original SARS, and SARS-CoV-2 emerged in their bat regions less than 10 years before they infected humans.
Okay.
And crucially, those regions were over 1,000 kilometers away from where the human outbreak started.
So you see this pattern with both SARS viruses, a big geographical jump.
Exactly. It looks very similar to what happened with SARS-CoV-1 back in 2003. The thinking there is it went from bats in Yunnan, again far away, to Guangdong province through traded animals.
Animals like palm civets.
Yeah.
Raccoon dogs.
Yes, things sold in live animal markets. And the pattern with SARS-CoV-2, starting far from the bat source but near a major market like Wuhan, looks strikingly similar.
And doesn't Professor Michael Worry also back this up, finding similar viruses in those kinds of animals far from bat areas?
He does. He points out we found SARS-CoV-2-like viruses in civets and raccoon dogs in southern China, nowhere near the main bat caves. And, the scientific consensus already accepts the wildlife trade route for SARS-1 covering hundreds of miles.
So seeing that same pattern again for COVID-19 is, well, it's compelling, isn't it?
It really strengthens the argument. And it also provides a strong counter to the lab leak theory.
How so?
Well, the study directly addresses the point that Wuhan is far from the bat caves. They say, look, this isn't unique to COVID-19. We saw the same large distance with SARS-1.
Right.
So this distance actually supports a natural spillover event, likely amplified and spread rapidly over long distances by the wildlife trade, rather than suggesting a lab accident near the outbreak site. Bats just don't travel that fast naturally.
Okay, so the big picture on origins. Wildlife trade seems a very likely facilitator for these long-distance jumps. Horseshoe bats are the primary hosts in the wild, and these are sarbecoviruses, part of the beta coronavirus family.
Exactly. And understanding this pathway is, well, it's fundamental if we want to prevent the next pandemic. The researchers really stress that point.
Absolutely. Okay, let's shift gears now to another really important and frankly concerning piece. Long COVID. That Journal of Nuclear Medicine study sounds quite revealing. What did it find?
It's quite sobering, actually. It provides really clear evidence of persistent inflammation in the heart and lungs of people with long COVID. And this is nearly a year after they first got sick.
A year later. Wow.
Yes. And here's the really worrying part. This inflammation was often found even when standard medical tests, the routine ones, were coming back completely normal.
So people are feeling unwell, genuinely having underlying physical issues, but regular tests might miss it entirely?
That seems to be the case. This is a pretty big study, the largest of its kind, looking specifically at heart and lung tissues in long COVID. They studied 100 patients who had persistent heart or lung symptoms after getting COVID between late 2020 and mid-2021.
And how did they actually detect this inflammation if standard tests missed it?
They used a really advanced technique called hybrid POTI MRI imaging.
PT-MRI.
Yeah, it combines two types of scans. MRI gives you a detailed picture of the organ structure, like the heart muscle and valves. PET scanning highlights areas where cells are highly active metabolically, which is often a sign of inflammation.
So you get structure and function or inflammation in one go?
Exactly. And they did these scans on 91 of the participants about 300 days, so nearly a year after their initial infection.
And what did these detailed scans actually show?
The results were pretty striking. They found signs of inflammation in the pericardium, that's the sac around the heart, in about 57% of those 91 patients.
More than half?
Yes. And it wasn't just the pericardium. They saw involvement of heart valves, especially the mitral valve, and also inflammation in the major blood vessels, the aorta, and the pulmonary arteries, often in multiple places.
That sounds quite extensive. Did they see other problems too, like scarring?
They did. In 22 patients, the scans showed abnormalities in the heart muscle itself, things like scarring or thickening, which could indicate past or ongoing issues.
Okay.
And specifically, pericardial issues, inflammation or fluid, were seen in 20 patients. Inflammation near the mitral valve in 10, and vascular inflammation, aorta or pulmonary arteries, in 28.
And crucially, did these findings actually match up with the symptoms the patients were reporting? Like chest pain, fatigue?
Yes, absolutely. There was a clear correlation. The people with these imaging abnormalities were the ones experiencing persistent chest pain, fatigue, shortness of breath. It gives a real physical explanation for those ongoing symptoms.
So it validates their experience, showing it's not all in their head. There's measurable physiology behind it.
Precisely. And they backed this up further with blood tests. They looked at plasma proteins involved in inflammation and immune signaling.
No.
They found abnormalities in key inflammatory biomarkers, basically molecular proof of the ongoing inflammation they saw in the scans. Importantly, they also had a control group, people who'd had COVID but recovered without ongoing symptoms.
And that group?
No inflammatory changes. Not on the scans, not in the blood work. It really highlights that these findings are specific to the long COVID group with persistent symptoms.
This is really concerning for the long term, isn't it? What are the potential future risks if this inflammation persists?
Well, the researchers raised concerns that these abnormalities could be early warning signs for serious conditions down the line. Things like heart failure, problems with the heart valves, pulmonary hypertension, even potentially premature coronary artery disease or narrowing of the blood vessels.
So potentially lasting cardiovascular damage. That's serious.
It really underscores the need to take long COVID seriously and find ways to treat this underlying inflammation.
You also mentioned a Nature immunology study. What did that add to the picture?
That study looked at the immune system itself. It found distinct, measurable changes in the immune systems of COVID survivors. And importantly, these changes were linked to how severe their initial lung damage was.
No, it's not just organ inflammation, but the whole immune system can be altered long term.
It seems so. It suggests a broader, systemic impact that can persist long after the acute infection is gone.
Okay, so we have the origins likely linked to wildlife trade and this significant issue of long-term inflammation. Let's pivot to the situation right now, in 2025. COVID isn't front-page news daily, but it hasn't disappeared, has it?
Not at all. Public focus has definitely shifted, which is understandable, but the virus is still circulating, and it's still important to know who's most at risk.
And that remains largely the same groups.
Pretty much. Older adults, people with compromised immune systems, maybe due to cancer treatment or other conditions, and those with underlying health issues like diabetes are still at higher risk of severe illness. And sadly, social inequities continue to play a role in outcomes too.
What about case numbers? You mentioned data from Australia. What does that tell us?
Well, officially, Australia reported around 58,000 cases in early 2025. But, and this is big, but testing is way down.
Right. People aren't testing or reporting like they used to.
Exactly. So the actual number of infections circulating is almost certainly much, much higher than those official figures suggest.
Any other data points? Hospitalizations?
Yeah, there's a surveillance system called monitoring 14 hospitals. In the first 3 months of 2025, They recorded 781 hospitalizations specifically for COVID complications.
And that's just 14 hospitals, so nationwide.
Nationwide numbers would be significantly higher, yes.
Yeah.
It gives us a glimpse, but it's just a snapshot. Sadly, there were also 289 deaths linked to COVID respiratory infections in the first 2 months. That number is lower than previous years, which is good, but still significant.
We're heading into winter in the Southern Hemisphere now. Are we expecting the usual winter surge?
We usually see more respiratory viruses in winter, definitely. But COVID has been interesting. The peaks haven't always been strictly seasonal.
Oh.
Yeah, over the last few years, we've tended to see surges roughly every 6 months or so, sometimes outside of the main winter season. So while winter might bring an increase, COVID seems to follow its own rhythm to some extent.
And the symptoms people get now, are they still the same? Fever, cough.
Mostly, yes.
Yeah.
Fever, cough, sore throat, runny nose, shortness of breath. Those are still the most common things to look out for.
What about the loss of taste or smell, anosmia? That was a big one early on.
It was very distinctive with the earlier variants, like Delta and the original strains. It became less common with Omicron.
Great.
But interestingly, studies are showing it's still being reported, even with the newer variants like JM1. Maybe not as frequently, but it can still happen.
So if someone gets symptoms like these, should they still bother testing?
Absolutely. Testing is still really important, especially if you have symptoms or if you know you've been exposed and you're in a high-risk group yourself or interact with vulnerable people.
Why is it still important?
Well, knowing if it's COVID helps guide treatment, especially getting antivirals quickly if you're eligible, and it helps you take steps to avoid spreading it.
PCRs are still the gold standard, I assume. What about the rapid tests?
PCRs are more accurate, yes. But rapid antigen tests, the R-reads, are useful for quick checks at home. You just have to remember, a negative R-read doesn't completely rule out COVID, especially if you definitely have symptoms. You might need to repeat the test or consider a PCR.
Okay. And if you do test positive, what's the advice now? Strict isolation.
Official rules have changed in many places, but the public health advice remains pretty clear. If you have symptoms, stay home. Rest, recover, and avoid giving it to others.
And if you absolutely have to go out,
Then take precautions. Wear a good quality mask, avoid crowded places, and definitely stay away from high-risk settings like hospitals or aged care facilities, and avoid contact with vulnerable people.
how long are people typically sick or contagious these days?
For most people with mild or moderate illness, it's usually around 7 to 10 days. The infectious period generally starts a day or two before symptoms even appear and lasts for about 10 days after they start. But if someone has a more severe case, they might be sick and contagious for longer. There was also a UK study suggesting that if you get infected again, the symptoms might be less persistent than the first time.
And vaccination helps with recovery too?
Definitely. Unvaccinated individuals tend to have more persistent symptoms. Vaccination generally means milder illness and quicker recovery.
Which brings us neatly to prevention. Vaccination is still key, right?
It's absolutely the best tool we have. It's incredibly effective at preventing severe disease, hospitalization, and death.
Do we have recent data on how well the vaccines are working against current strains?
Yes. Data from Europe's recent winter show the vaccines were around 66% effective against getting symptomatic confirmed COVID, which is pretty good protection against just getting sick at all.
And their recommendations in Australia now, is it still boosters?
Yes. A primary dose is recommended for all adults. Then for most adults, a booster is recommended every 12 months. But for those at higher risk, people 65 and over, or adults with weakened immune systems, more frequent boosters, say every 6 to 12 months, are advised. It's always best to check the latest official advice for your specific situation, and you can usually check your vaccine history online.
What about long COVID? Does being vaccinated beforehand make any difference?
Encouragingly, yes. A review looking at multiple studies found that being fully vaccinated before you get infected reduces the risk of developing long COVID by about 27%. That's quite significant.
That's definitely good incentive.
It is. And also, this concept of hybrid immunity, having immunity from both vaccination and a past infection, seems to be playing a big role in keeping large-scale waves somewhat suppressed.
Okay, let's just circle back briefly to the origins discussion. The cell researchers had a warning about the future, didn't they, linked to that wildlife trade finding?
They did. A stark warning, really. They emphasized that the risk of future pandemics, new diseases jumping from animals to humans, is actually increasing because of things like ongoing habitat destruction, increasing urbanization, pushing people and wildlife closer together, and crucially, the continuation of the global wildlife trade.
So the conditions that likely led to COVID-19 are still very much present.
Yes, and they stressed the vital importance of continuing to monitor these sarbecoviruses in bat populations and potentially in traded animals. Early detection is key if we want to spot the next potential threat before it explodes.
Right. Okay, so quite a journey today. We've covered the likely wildlife trade link in COVID's origin story, the really concerning findings about persistent heart and lung inflammation in long COVID, and the fact that, while things have changed, the virus is still here, and prevention, especially vaccination, remains critical.
Absolutely. The aim was to synthesize this complex information, drawing from those key studies in Cell, the Journal of Nuclear Medicine, Nature Immunology, and the latest Australian data, all brought together via DTE to give you that clearer picture.
And what really strikes me is how connected it all is. The origin informs prevention, and the long-term effects highlight the deep impact this virus has had, well beyond just the initial illness.
Exactly. The zoonotic origin story really hammers home the need for a One Health approach, understanding that human health, animal health, and environmental health are all linked. And the long COVID findings show we're still grappling with the full consequences.
So a final thought for you listening. Considering all this evidence, the origins, the long-term impacts, the current situation, what do you think are the most critical steps for us as individuals and for our global communities to lessen the risk of future pandemics and properly address the lasting health challenges of COVID-19? It's a complex question.
And for those of you preparing for the UPSC exam, this deep dive touches on so many relevant themes. Understanding the science behind pandemics, the public health responses, the long-term socioeconomic and health impacts, this is all core knowledge. It's not just about memorizing facts, but grasping these complex, interconnected issues, which is vital for the civil services examination.
Absolutely. If you found this helpful, please do like, subscribe, and maybe leave a comment if you have more questions. We really want to tackle the topics that matter to you. And remember, all the information discussed today came from those sources we mentioned, curated through DTE.
Thanks for joining us for this deep dive.
See you next time.